Hello, everyone. So we're gonna go over the Unit One exam final study guide. We are taking our test this week, so here's the way that we should expect our questions to look like when it comes to the unit exam. So the first one says piano lessons. So the two box plots summarize the number of hours students from two different schools spent practicing the piano last week. So it says which of the statements must be true, right? Must be true about the distribution that the data represented in the box plot. So in this case, the first thing I want to do is identify where school A and B are. So this is school B, this is school A, right? So if I'm looking at that, now I could start figuring out what they're asking me as far as the statements. And again, I'm looking at which ones to be true. So the first one says the median practice time. So we're looking at the median, right? So for school A, in this case, so we're looking at school A, it says is greater than the median, right, for school B. So this is saying that the median for school A is it's greater than the median for school B. So let's take a look at that. Well, if we remember, the median in this case will have to be in the center. So this, if we're looking at school B, we're looking at this value here. So if we look down, that's approximately, I would say, like 7 or 7.5, right? So approximately there. And then if I'm looking at school A, sorry, then I'm looking at this line, and that's somewhere around 5.5 or 5, right? So at this point, based on that, we could see that, again, it says the median for practice for school A, that's the 5.5, is greater than B. So no, that is not true, right? So in this case, that's not true, so we could eliminate A. That one's not correct. So not true. And then it says the inner quartile range, right? So inner quartile range is the same thing as the IQR. So I'm gonna make a note for myself. So for school A, it says that it's gonna be larger than the IQR for school B. So in this case, I'll have to figure out the IQR for both of these. So if you could recall, IQR is found by doing Q3 minus Q1. So in this case, if I'm looking at this, so my Q1 will be here, my Q3 will be here, my Q1 will be here in the front of the box, my Q3 is right here. So in this case, right, I'm going to zoom in a little bit. Looking at Q1 for this one, this is around here. So that looks around, again, I'm approximating, so it's 6, 7. So this is 7. So I would say approximately 6.5, right? And then the top quartile is around 9, right? Actually, I'm gonna just say this one. So I'm gonna approximate it. So this is the kind of in the middle. So 7 and 7, and this one's 9. And then let me just erase this. So this was. So at this point, again, that's 7, that's 9, and then I'm looking for the Q1s for school A now, right? So in this case, this is around approximately 3, right? So very close, and this is around 7. So at this point, if I'm finding the IQR for school A, then I'll have to do 7 minus 3. Again, that comes from the IQR equation here, right? So 7 minus 3, and that gives me an IQR of 4 versus the IQR for school B, in this case, will be 9 minus 7 approximately, and that gives you 2. So in this case, again, inner quartile range, so IQR for A is greater than school B. So in this case, we will say that yes, that is correct, right? So that is a correct statement or true statement in this case. And then lastly, it says the maximum practice time for school B. So again, the max practice time for school B is greater than the maximum practice time for school A. Well, For school B, the maximum amount of hours was around there, so around 11, I'd say, right? So equals 11 hours versus the max that this one had was approximately, sorry, I didn't change the color, so I'm gonna change the color. So it's approximately here, and that is around 9, right? So in this case, we could see that school B actually, um, school B actually had a larger amount of hours that were studied, right? In this case, 11 hours versus school A was only, the max was 11. So I'm going to write that down here. So this one was 11, and then this one was only 9 hours. So in this case, it says that B has a greater amount. So yes, that is correct, right? That is true in this case. And then lastly, players at school A spend the same total number of hours practicing as school B. Well, in this case, we would need like every single data point, right, in order for us to know how many hours they actually spent. In this case, we only have the box plot, right? And when we have a box plot, we have to recall that all we could really know is the minimum, Q1, the median, Q3, and in this case, the max as well, right? So we're not, in this case, we're not able to know if that's true or false because we don't have the complete data to back it up. So that was question number 1. Now we're looking at question number 2. So it says, so this is about study time, right? So it says the dot plots show the number of weekly study hours for 2 groups of students. So it says again, select all the statements that must be true. So if we look back up here, right, it's like which of the statements must be true. And this one we also see select all, right? So we want to just make sure that anytime we see that, we are just extra careful to observe that we have all of the possible answers in this case. So for the first statement, it says group 2. So again, I'm going to identify which is group what. So I'm going to make group 1 red and group 2 blue, right? So in this case, it says group 2 has a greater variability. Again, that's a spread. We're measuring spread, right? Like how spread out it is from the center. It says that it has a greater variability than group 1. So is that true? Well, let's see. If we look at group 1, we kind of see that most of it is kind of sort of like centered, right, still. Versus here, we could see that there's a higher spread in this case, right? So that means that we have a high variability, right? So there's a lot of spread. So in this case, group 2 has a high, yes, in this case, that is true, right? It does have a higher spread. Now looking at the second one, the mean study hours of group 1 is higher than group 2. In this case, the way you could approach this one would be, sorry, let me just erase that. So the way that we could approach this one is one of 2 ways. So we should be able to look at kind of the data, right? And we see that most of it is kind of pretty symmetric. So we know that the mean is going to be somewhere in the center. So approximately 7 hours, right? But here we kind of see that even though we have data on the right-hand side, now we also have data on this side. So because we have outliers on the right-hand side, this is going to push our mean, right? So it's going to push our mean into the positive direction. So in this case, it says the mean for group 1, right, is greater than for group 2. In this case, we could also calculate every single one of these values, right? So in this case, I know that the mean for group 2 will actually be higher. But if you wanted to calculate and confirm, right, which is always a great idea. Let me just erase this real fast. So if you guys wanted to actually calculate it, you guys could also do that, right? So for this one, there's 1 at 2, so you could do 2, and then there's 3, right? This is in the middle, so 3, 1, 4, 5, 5, 6, 6, 6, and so on, right? I could list them, add them, and then divide by the number of numbers in this case, right? Same thing here. We could do that same thing for group 2. I have 1, 1, 2, 2, 3, 3, etc., right? So I would add them and then divide by the number of values in this case, right? And then we could compare which one had it. But again, I've already calculated, and we could see that you will be able to find that the mean is actually higher for group 2. So that's not correct. Then it says the medians of the groups are about the same. For this one, again, we have a visual, so we could kind of just take it from the ends, right? Kind of go one by one on each side till I get to the center. So I get one left, one right, 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 one left, one right. And so we have these two values in the middle. When I add them and divide them, so the median in this case would be 7. And then you could do the same exact thing for the second group, right? We could just kind of go one left, one right, one left, one right, one left, one right, until we find the middle, and we find ourselves here. So one value of 5, one value of 6. So the middle of that will be around 5.5. So the median in this case will be 5.5. So they're about the same. 7 and 5.5, they're not. If it was 5 and 5.5, maybe, but in this case, you could say no, they're not about the same. Then it says D, group 2 contains an outlier that affects the mean more than the median. So again, kind of just to be able to see the whole entire data set, right? I'm just going to erase this. And if you need to just go back in the video, you'll be able to see the other problem. But in this case, again, group 2, so we're looking at group 2, it's right here, contains an outlier that affects the mean more than the median. Well, first let's check if there's even an outlier. Well, in this case, we have a bulk here, but then it's almost out, and then we have a set of values here. So there is a lot, definitely, of separation from the main bulk. So we could consider these to be outliers, right? Because they're away from the other rest of the data. But then we have to think about it. Group 2 contains an outlier that affects the mean more than the median. Well, when we did the discovery, we did see that when we have outliers, right, we tend, the only thing that tends to move is the mean. And if we remember, the median is like the statue, doesn't move. So in this case, since we had outliers move it to the right, the mean will shift also to the right. So therefore, yes, in this case, we could say that group 2 contains an outlier and that it affects the mean more than the median. And be careful there, because they might try to trick you, right? They might say that it affects the median more than the mean. But no, the median is more like the statue, right? And then the mean changes in this case. And then it says only using group 2's data, right? So we're looking just at group 2 in this case. So only looking at group 2's data. And again, I'm going to erase this to kind of visualize this, right? To see the visual. It says, so if I'm looking at this data, the mean is equal to the median. Well, the only time where, in this case, the mean is the same as the median is when we have a symmetrical distribution, right? So if we had a symmetrical, and that's when the mean is equal to the median. And in this case, since we're looking at group 2, we do not have a sense of symmetry here, so therefore it's wrong. If they would have asked it, however, about group 1, here we actually do see that there's a very close symmetric distribution. So we could say that this one will be closer, right? We could be equal to the median. It'll be closer than we did for in this case for group 2. So again, when they're asking us, we got to ask ourselves, is this symmetrical or not? Now looking at question 3, it says the dot plots show the number of goals scored in 8 soccer matches by Team A and Team B. So again, we have 2 different teams. So I want to make sure that I will kind of make that distinction between what team I'm looking at every single time when I'm answering the questions, right? So I'm looking at 2 distributions here, and it says Team A. Sorry, I'm gonna go. Team A is red, so I'm gonna go. Team A scores have less variability, right? Less spread than Team B. So in this case, do we have less spread? That means that we have that the values for Team A are closer to the middle, right? And in this case, we could see that yes, that is actually true, right? We kind of have the majority of the book here. Sorry about that. The majority of the book in the middle versus in this case, we could see that there's definitely a higher spread for B. And again, I'm trying to use the color coding, and then I'm not using it. So yeah, there's more spread here, which tells us that there is a high variability, right? So in this case, Team A has less variability than Team B. So yes, that is true in this case. That is true, right? The median, now again, we're looking at the median, right? The median in this case for B is greater than the median for Team A. Well, let's start with B. Well, what's the median? Well, again, I could kind of just look at the middle. They're both symmetrical, so I should be able to find it in the middle of those two values. So in this case, of 4.5. And same thing this with A, right? It's symmetrical. You can see it's like the same in both ends. It's terrible. There we go. So again, the middle of that is around 2.5. So in this case, the median of scores for Team B is greater than the Team A. So in this case, yes, that is also true, right? We have 4.5 versus 2.5. And then it says Team A scored more goals than Team B in every match. Well, again, I'm going to erase this, right? And in this case, is asking that the Team A scored more goals than Team B in every match. Well, there was one goal that was scored in one of the matches, right? If we're looking at the first one, right? So that means that Team A did not score more goals in that match. So at that point right away, I could see that were equal, right? So this one was saying that Team A scored more goals in every single match. So I'm going to take that very literal. So in this case, I disproved it just already the first one. But I could look at the second, right? We scored 2 goals in 1, 2, 3 games. And like here, same thing, right? It was once only for Team B. So in that case, that one was more. This one was more. But then here's the same. This one didn't score anything. So this one, Team B is actually more. So there you go. There's a few ways to disprove that is not true. And then it says the mean number of goals for Team A is less than for Team B, right? So in this case, again, what I recommend if you can't see it visually is that you write down the values for each of the dot plots. So in this case, it's red. So I'm looking at 1, 1, 1, 2, 1, 2, 3, 2. So 1, 1, 2, 3. Oops. And then 3, 3. So 1, 2, 3. And then 1, 4, right? So in this case, again, add them and divide by the number. And in this case, for the second one, same thing here, right? You could do 1, 2, 3, 4, 5, 6, 7, 8, and 9. Actually, there's no 9, so it's up to 8. 1, 2, 3, 4, 5, 6, 7, 8. Again, divide that by the number of values. And in this case, I'm actually going to do it real fast. I'm going to use my calculator. But same thing with you. You should be trying this on your own. So 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 divided by, how many values were there? 1, 2, 3, 4, 5, 6, 7, 8. Divide that by 8. So I get that it's 4.5. Right? And same thing here. We could see, we could add them, and then we're actually going to get 2.5. And I don't have to calculate it, because what I realize is that these two are symmetric. So I know that the mean and the median are the same. That's in the middle. That's 2.5. Same thing with this one, right? There should be this is symmetric. It's uniform. So 1, 2, 3, 1, 2, 3, 1, 2. So this is in the middle of these two, right? So So that means that's at 4.5, and it works out, you see? So therefore, here's the mean number of goals for Team A is less than Team B. So yes, it is actually less than, right? So that would be one of them. And then lastly, Team B scores include an outlier that increases the mean. Well, let's check. Does it even have an outlier? Let's check that out first before we say yes or no, it impacts something, right? So in this case, for Team B, that is blue. So in this case, again, we have this uniform approach, but there's really no outliers. I don't see anything outside of that, right? It's just kind of like just a uniform. So no, there's no. This case there's not even an outlier for me to look at. So the only answers was A, B, and D. The next one is we're looking at a histogram. We already could kind of see that, right? But it's similar to one we've seen in the past. It says books read per year. So it says the histogram shows the 20 students who read the fewest books this year. So it says, so they already have it here, right? So it already shows that 20 students who read the fewest book this year. So it says for me to complete the histogram, adding the 10 students who read the most, right? So where is that data at? Well, the data is right here, right? This is the one we have to plot. And like here, it tells me that I have to create a frequency table. So they already kind of gave me a hint. And I'm going to need an interval and then measure the frequency, right? How often it occurs. So in this case, I'm going to see here, if I look, the data they plot is stopped at 15. So that means that when we start, it should be starting at this value of 15. And I could also see that they're giving me the intervals that I should use, right? I don't have to rethink that. So in this case, we have 15 through 20, 20 to 25, and 25 to 30. And one of the things that we have to remember, this is, we read it as values that are 15 or greater but less than 20. Values that are 20 or greater but less than 25. Values that are greater than 25 or greater but less than 30. So again, if I'm looking at these values, I'm going to see this 15, can we put them, what can we put in this bucket, right? So 15, yes, that fits in there. So we could do 15, 16, yes. 18, yes. 20. Well, 20, again, this interval says, right here, says values that are 15, right? Or greater but less than 20. So, no, it has to be less than 20. So we only have a frequency of 3 there. Then 20, it fits in the next bucket, yes. 22, yes. 24, yes. 25, no, right? It's not. In this case, we cannot write that one down. So, technology. So 3, and then the last two we have 25. The next bucket, yes. 26, 27, 28. So that's 4, right? So all I have to do in the test, this will be more of a tech problem, right? You're going to have to be able to, sorry, I can erase this. All right, there it is. You're going to have to actually drag the frequency table up or down, okay? So you're going to have to be able to do that in the test. Sorry, I don't like it's different color. So in this case, again, for the interval 15 to 20, it went to 3. So I'm seeing that this is actually 1 because it's going by 3s, right? So 5. So I'm just going to zoom in a little bit to get this. So 3 is around here. Oops. Right, so somewhere there. And then we had the same exact thing, so I'm actually just going to extend it. Oops. And then so 3, I'm just going to write it. You don't have to write the values. I just like to write them to make sure I'm following this. And then the last one, 4, right? So I could go all the way to 4. And this is the value of 4. And if you wanted to shade it, you can shade it. You don't have to. And again, in the test, it'll be more of a, like, pulling it, like, up or down. Okay? So just make sure that you have that correctly. Question number 5. So we're looking at commute times. So it says the histograms display commute times in minutes for individuals that residing in the city and the suburbs. So it says which group has a greater standard deviation? Again, we've talked about this quite a bit. So the variability, the spread, from the middle, right? So in this case, we could kind of see that this distribution is more like definitely a lot of spread here versus this one, right, is more of a concentration in the middle. So therefore, this one has a low SD and this one has a high SD. So therefore, this one's pretty simple. Again, a freebie is the suburbs, okay? That's the highest variability. We have the highest spread in this case. That question number 5. So number 5 is just kind of gives us this dot plot as well, and then they ask us a couple of questions. So it's going to be greater for team X, equal for both, or greater for team Y. So in this case, the number of athletes who track the exercises minutes. So in this case, well, how do I know how many students there were, how many athletes? Well, in this case, every single one of these dots represents a student, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So this one had 15 students. And then this one, actually know that it has also 15 students. If you don't believe me, count them. So because of that, right, it's the number of athletes who track the exercise minutes greater for team Y, equal for both, or equal or greater for team Y. So obviously they were the same in this case, right? So we could just say it's equal for both. The maximum number of minutes exercise. Well, I kind of have to look at that, right? So we have to look at our dot plot. So in this case, what was the highest amount? Well, these were the only two, and they exercised for 30 minutes. And this one's the highest. And even though it's not a perfect, like, you can know exactly where it's at, you could like approximate. You could say either 31.5 or even 32, right? But you could definitely see that this one's higher to the right. So in this case, it'll be greater for team Y. And then the last thing is the mean, right? So the mean value. So in this case, the way we could do that again, if we do not see this, right? And I'm going to write this that there's 15 students over here and then 15 students, just in case we need that. But in this case, right, we could see 1, 2, 3, 4, 5, 6, 1, 2, 3. Okay, so in this case, I was just trying to see if this is symmetric. So I know that this one's symmetric down here, right? So the value is a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 15. So 15 values. So that means that it'll be 7, that's 14. So the 13th value is the middle in this case, right? So in this case, we're gonna go back. So 1, 2, 3, 4, 5, 6, 7, 8. So 8, the 8th one is the center. So in this case, we know that the mean is 25 because, again, it's symmetric. This one's not very symmetric. It's closely symmetric. And it's definitely close. But knowing me, I would just kind of like try to figure the values. This one's a little like closer, right? But because of this one, let me just verify my notes as well, just to make sure, right? I just want to verify. In this case, we have 25, but in here, these values, right, for team Y, we could see that we have like outliers to the left, right? So we know that the mean's going to get pulled more to the left. So in this case, if you were to calculate, you actually get to arrive that the mean is actually greater for team X, because most of them we kind of see is kind of like in the middle, right? Versus this one, we kind of see more of that spread. So in this case, the mean number of exercise was greater for team X. The last one, sorry, and then for this one, the dot plots that they'll have, it won't be something that you have to guess what the values are. You actually should have a dot plot where you could really read what the values are every single time. So just know that will happen for the test. Now looking at this next one, says the dot plot show the salaries for employees at 2 different companies. Select all the statements that must be true, right? So in this case, again, it says we can kind of see in this case, well, what type of distributions we have. Well, in this case, we definitely have a symmetric distribution. And this one, we definitely could see that. Um, my pen actually died, so I'm gonna have to create this video as a second part in the next one. Thank you.